Dear students, in the last video lecture, I started the 8085 pin configuration description. In this lecture also, we will be continuing the same topic. So, I told you that the 8085 microprocessor has 40 pins, and these pins are classified into these 7 classifications. So I discussed about the power supply and frequency signal pins. I discussed data bus and address pins. I was discussing about control and status signal pins. So in control and status signal pins, I discussed about ALE, RD bar and WR bar. I told you that ALE is address latch enable, and it is used for latching the lower address of the 16-bit address. It is used for latching the lower byte of the 16-bit address to make the 80 to 87 lines free for transferring the data. Then I discussed about RD bar and WR bar signals, that if the RD bar signal is low, then it gets activated and it is used for reading purpose, and if the WR bar signal is low, it will get activated, and it means that microprocessor wants to write something either on the memory location or input output device. So the next pin of this control and status signals is IO/M bar. So IO is input output, M represents memory. So IO/M bar, it is a status signal which distinguishes whether the address bus, that is AD0 to AD7 and A8 to A15, means A0 to A15 address bus. So it is a status signal which distinguishes whether the address that the address bus is carrying is for memory or for input output. So when this IO/M bar is high, means the address on the address bus is for input output device, and when the IO/M bar pin is low, it means the address on the address bus is for memory location. So the microprocessor uses IO/M bar signal to indicate whether it will communicate with an input output device or memory. So here I have drawn a table that RD bar, WR bar and IO/M bar, how does it work in combination. As you can see, the first two rows, RD bar and WR, both are low simultaneously, but both can't be low simultaneously. If both are low, means both get activated, but we cannot activate RD bar and WR bar signal cannot get activated simultaneously, because then an error will occur, because RD bar means transferring of data from memory or input output device to microprocessor, and WR bar means transferring of data from microprocessor to input output or memory. So both are the opposite of each other and both cannot be activated simultaneously. Now let's see the third row, where RD bar is 0, WR bar is 1 and IO/M bar is 0, which means RD bar gets activated, and in IO/M bar is 0, it means M bar is activated, that is memory is activated. So combining this, I'll get that in the third row, memory is activated and RD bar is activated, means memory read operation is to be performed, which means the address on the address bus, the microprocessor will send an address through the address bus, and that address is for memory location, and from that memory location read operation will be done, that is from that memory location data will get transferred to the memory through data bus. Similarly, the fourth row represents RD bar 0, WR bar 1 and IO/M bar 1, which means RD bar signal gets activated, that is read operation has to be done, and IO/M bar is 1, which means input output device input output is activated. That is, the read operation is to be done from an input output device. So the address on the address bus is for input output device, and from that input output device the data will get transferred to the microprocessor. Similarly, the next row, RD bar is 1, WR bar is 0, and IO/M bar is 0, which means WR bar signal gets activated and M bar signal gets activated, means memory write operation has to be performed, which means address on the address bus is for memory, and the microprocessor is going to send some data through the data bus into that memory location. So in this way, memory write operation is performed. So similarly, for input output write operation will get performed the same way, and the signals, that is the status of these pins for input output write, will be RD bar will be 1, that is it is deactivated, WR will be 0, and IO/M bar will be 1. So the next set of pins is S0 and S1. So S0 and S1, these are status signals that which are sent by the microprocessor to distinguish various types of operation, or to indicate type of machine cycle which is in progress. So here are the various combinations of S0 and S1. If S0 and S1 both are 0, 0 simultaneously, means the microprocessor is in halt state. So if the S0 and S1, if S0 is 1 and S1 is 0, means some writing operation is being performed by the microprocessor. If S1 is 1 and S0 is 0, then it indicates some reading operation is being performed through the microprocessor. The microprocessor is performing some reading operation, and if both are 1, means fetching is occurring. That is, either opcode fetch or fetching of data is taking place. So through S0, these are the status signals that will tell you, S0 and S1 will tell you that what type of operation is being performed. So these were the signals: S0, ALE, WR bar, RD bar, S1, IO/M bar, and the last one that is remaining is ready. So for what purpose the ready is used? So basically, ready, it is used by the microprocessor to sense whether a peripheral is ready or not for data transfer. The microprocessor examines ready signal before it performs data transfer operation. That is, when ready is high, it indicates that the input or output device is ready to send or receive data. When ready is low, the microprocessor waits till ready becomes high. So the microprocessor examines the status of ready signal in the second clock of the machine cycle. I'll tell you what is machine cycle in the next topic. So basically what happens in this slide only, you just get this idea that ready is the spin which is examined by microprocessor to check whether the input output device is ready to send or receive data or not. So basically this ready pin is thus used to synchronize slower peripherals to the microprocessor. If the input output device is not ready, then the microprocessor goes to the wait state. So here are all the pins that I have discussed under the classification control and status signal pins. The next classification is interrupt and DMA signal pins. So we'll continue in the next lecture.